Two scrubs, one engine abort right at the pad. If you have followed the Starship program for any length of time, you know how rare it is to get a truly clean test flight out of this vehicle. Flight 13 came about as close as this program has ever gotten, and there is a lot to get through here. From the engines to a booster splashdown that almost went sideways to a satellite deployment that finally used real hardware instead of dummies. So grab a coffee, here is how Flight 13 actually went down. It helps to understand just how different version 3 really is under the skin, because this is not a small refresh. The new Raptor 3 engines carry far less external plumbing than the previous generation, which cuts down on the amount of exposed hardware that can catch fire or leak inside the engine bay, an area that caused real headaches on several version 2 flights last year. Booster 20 is only the second Super Heavy ever built to this new specification, and it trades the old 4-grid fin layout for 3 larger fins, along with a fully integrated interstage that replaces the temporary hot stage ring earlier ships used to jettison away mid-flight. Ship 40 carries its own list of changes too, most of them invisible on camera but important underneath, including more mature thermal protection around the engine bay, upgraded actuators on the payload dispenser, and early hardware meant to support future orbital refueling and docking work. It is worth remembering just how new this hardware family still is. Booster 20 is only the second Block 3 Super Heavy to ever leave the factory, which means SpaceX still has a very small sample size to learn from every time one of these boosters flies, and every flight teaches them something the last one could not. SpaceX pulled the booster apart, found 6 engines with issues, and swapped every one of them out. A second attempt on July 23rd got scrubbed too, this time for something almost mundane. The ground cameras tracking the heat shield during Ascent needed clear skies, and the weather over South Texas would not cooperate. By the time Friday, July 24th rolled around, this was already the 3rd try at getting Flight 13 off the ground, and the pressure had only gone up. At ignition, all 33 Raptor 3 engines on Super Heavy lit together, and every single one of them stayed lit. That is worth sitting with for a second, because a clean startup across all 33 engines has not always been a given on this program, and it certainly was not a given a week earlier when 4 engines couldn't even reach ignition on the pad. Water and detonation suppression systems flooded the flame trench beneath the pad the instant those engines caught, and the vehicle climbed off the tower, producing somewhere around 18 million pounds of thrust, more force than any rocket ever built. The entire stock, more than 400 feet of stacked steel, pulled itself off the ground and out over the Gulf of Mexico, trailing a column of fire that looked almost too big for the frame to hold. About 2 minutes into the flight, Super Heavy and Ship 40 separated using the same integrated hot staging system introduced back on Flight 12. A handful of the booster's inner ring engines stay lit right through the handoff, which keeps the propellant settled in the tanks while Ship's own engines light up above it and pull the two vehicles apart. From there, the two halves of the rocket went their separate ways, and honestly, this is where Flight 13 started to look like a genuinely different animal from Flight 12. Super Heavy flipped around for its boostback burn, and unlike in May, actually nailed it clean. The booster arced back toward the Gulf of Mexico in a controlled descent, which on its own was already an improvement, since Booster 19 never even made it that far before its engine started acting up. The real test came about 7 minutes after liftoff during the landing burn. Super Heavy was supposed to relight 13 engines for that final touchdown, but not all of them came back online. The booster hit the water going faster than SpaceX wanted, in what SpaceX commentator Dan Hoot describes on the broadcast as coming in a bit hot. It was not the soft touchdown the team was hoping for, but here's the difference that actually matters. Booster 20 stayed in one piece and splashed down largely under control, instead of tumbling apart the way Booster 19 did back in May. SpaceX always intended to throw this particular booster away in the ocean rather than attempt to catch, so a rougher than planned splashdown was not a mission-ending problem. It was, though, a clear signal that the boostback flip itself is solved for this new booster, while relight reliability specifically on that low-altitude landing burn still needs real work before anyone trusts a version 3 Super Heavy near the tower again. While all that booster drama played out, Ship 40 was having a nearly flawless day. all 6 of its Raptor engines burned clean for the entire ascent, which might not sound dramatic on its own, but Flight 12 lost one of its vacuum engines a few minutes into the climb and had to stretch its burn time to compensate for the missing thrust. Not this time. Ship 40 hit its target trajectory with every engine doing exactly what it was built to do, coasting into the same suborbital arc that has carried every Starship upper stage since the early flights, fast enough to circle most of the planet, but not quite fast enough to stay in orbit on its own. This time, 20 fully operational Starlink V3 satellites rode inside that bay, and one by one they slid out through the same slit-style dispenser SpaceX engineers have nicknamed the Pez dispenser, after the candy toy for anyone too young to remember it. Each of these V3 satellites weighs around 2,000 kilograms, roughly 6 times heavier than the original Starlink units from a few years back. And once clear of the ship, they unfolded their solar arrays and antennas and tried to check in with the rest of the Starlink network. SpaceX engineer Kate Tice confirmed on the broadcast that every single one of the 20 made contact, both over standard radio links and over laser inter-satellite links, reaching all the way to a ground station in South Africa. That deployment matters more than it might look at first glance. Starlink is the one part of SpaceX's business that already generates steady, reliable revenue, and that revenue is what funds a huge chunk of Starship's own development. Once Starship is flying routinely, SpaceX expects each launch carrying V3 satellites to add somewhere around 60 terabits per second of fresh network capacity, more than 20 times what a single Falcon 9 Starlink mission can deliver. Getting real, powered V3 hardware through a clean deployment sequence like this one is worth more to SpaceX's bottom line than almost anything else that happened this week, even with all the drama around the booster. 6 of those 20 satellites carried something extra. Cameras aimed straight back at ship's heat shield. SpaceX had even painted a handful of tiles white on purpose, standing in for missing tiles, just to see whether these orbital cameras could actually pick up damage from a distance. If that trick holds up over more flights, it becomes a real inspection tool, one that lets SpaceX check a heat shield's condition from orbit before deciding whether a Starship is even safe to bring home and fly again. Somewhere in the middle of all that satellite activity, Ship also pulled off a milestone that Flight 12 had to skip entirely. It relit one of its Raptor engines while coasting through the vacuum of space. Flight 12 could not attempt this because losing that vacuum engine early in ascent meant the ship needed every drop of remaining propellant just to reach its target trajectory, with nothing spare left over for a Relight demo. This time, with a full and clean ascent behind it, Ship had margin to spare, and the Relight went off without a hitch. That capability reaches well beyond this one test. Any future mission involving orbital refueling, a lunar landing, or eventually a trip to Mars depends on Starship being able to reliably restart its engines after coasting through the vacuum for extended periods. Flight 13 just proved that piece of the puzzle actually works, and NASA is watching this specific milestone closely. The plan for landing astronauts on the moon under the Artemis program calls for a modified Starship to launch mostly empty, meet a separate propellant depot already waiting in orbit, and transfer fuel from one vehicle to the other before it has enough in the tank to actually head toward the moon. None of that works if the engines cannot reliably restart after sitting in freezing vacuum for a while. So a small in-space relight like the one on Flight 13 is really a first modest rehearsal for a maneuver NASA is counting on for a much bigger mission, with a critical uncrewed demonstration flight already on the calendar for next year. With the satellites away and the relight demonstrated, Ship 40 turned toward home. Reentry began the way it always does, with a thin halo of plasma building around the vehicle as it slammed into the upper atmosphere at more than 20 times the speed of sound, the telltale pink glow visible even through the grainy onboard cameras. Underneath all of that heat sits Ship's thermal protection system, thousands of individual black ceramic tiles built to shed heat rather than absorb it, and this is the part of the Starship program that has quietly needed the most repeated fixes over the years. Watching this pass, the vehicle held its attitude cleanly through the worst of the heating, without the kind of debris shedding or flap burn through that showed up on some of the earlier version 2 flights. By the time Ship dropped below hypersonic speeds, it was already lining up for its final final flip and landing burn, the same maneuver every Starship has attempted since the early days of this program, just this time running through the redesigned version 3 flap and engine layout. Out on the water, this whole operation had turned into a genuinely global effort by this point in the program. Off the Texas coast, recovery boats sat waiting for Super Heavy's splashdown in the Gulf. On the other side of the planet, camera-equipped buoys bobbed in the Indian Ocean west of Australia, positioned exactly where Ship 40 was supposed to come down, ready to catch the final moments on video. It is easy to forget how wild that logistics picture actually is, coordinating splashdown zones on opposite sides of the Earth for a single test flight for a program that was still exploding on the pad just a few years ago. And then, splashdown. Ship 40 touched down in the Indian Ocean almost exactly 1 hour after liftoff, right on the mission's planned timeline. SpaceX's own broadcast team called it the softest splashdown any Starship has ever made, and Dan Hoot did not hide how happy the team was about it, calling it close to a dream outcome for anyone trying to pull good heat shield data out of a test flight. Just like every Starship splashdown so far, that part is expected, not a failure. What actually matters is that everything upstream of that moment, Ascent, Deployment, Relight, and Reentry, held together better than it ever has on this program. So where does that leave the Starship program right now? Super Heavy clearly still has homework to do on its landing burn reliability before SpaceX trusts it near an actual tower catch attempt again, even though the boostback and flip that doomed Booster 19 back in May now look solved. SpaceX has caught a Super Heavy booster with the tower arms before, going all the way back to Flight 5, so the basic mechanics of a catch are not new to this program. What Flight 13 exposed is a narrower, more specific problem, getting enough engines to relight cleanly during that final low-altitude burn, at the exact moment when there is no room left for hesitation. Almost everything else about this flight points in the right direction. A clean engine start across all 33 Raptors, a full 6-for-6 burn on the upper stage, the first ever deployment of production Starlink satellites instead of dummies, a successful vacuum engine relight, and a re-entry that looked more controlled than almost anything this program has flown before. As for what comes next, SpaceX has already said it wants a faster turnaround toward Flight 14, and with NASA's Artemis lunar lander timeline hanging over this program, they genuinely cannot afford to slow down now. If Flight 13 is any real indication of where version 3 is headed, the next few flights might finally be the ones where a Super Heavy booster makes it back to the tower in one piece, and Starship gets a real shot at proving out orbital refueling for the first time. After 3 attempts just to get this one mission off the ground, that kind of momentum is exactly what this program needed heading into the back half of the year. That is Flight 13 start to finish. Let me know in the comments what stood out most to you, whether it's the Relight, the Starlink deployment, or that booster coming in hot off the landing burn. And if you want to be here for the next one, get subscribed now, because if SpaceX keeps this pace up, Flight 14 might not be far away at all. Thanks for watching, and I will catch you on the next launch.